Hi everyone, I'm going to show you guys how to solve this MIT integral, and I'm not sure of which year this is from. I think it's from 2024. So you guys have probably seen this question, and there are many ways of doing this. So I'm going to do it using integration by substitution. Well, if there are easier methods of doing this question, you could share it in the comment section. And if you guys like what I'm doing, and if you guys like my teaching, you can leave a like and subscribe. And yeah, let's get on with the question. So what I'll do first is I would take the numerator to a denominator. Since it's x to the power minus half, we could make it root x, right? Into 1 plus x to the power 1 over 3, right? So then I'll take a substitution of u equals root x. So du over dx equals, so this is x to the power half, so half comes down, and the power is subtracted by 1, right? So it's x to the power minus half over 2, right? Du over dx. So we should subject dx now. So it's 2 into root x du equals dx. I hope you all understood that. Because when I take this onto the other side, I divide both sides by x to the power minus half, right? So we're going to have x to the power minus half in the denominator. So what I did was just I took it to the numerator since it's minus half. I hope you all understood that. So now you can put in the substitution. So we have 1 over root x. And we also have to find x to the power 1 over 3 in terms of u. We'll do that next. So dx is going to be 2 root x du, right? So you cancel off root x. You can take the 2 out. I'll leave it like that for now. Let's find x to the power 1 over 3 in terms of u. So if u equals x to the power half, what's x to the power 1 over 3? So to get x to the power 1 over 3, can you see that we'll have to put powers of 2 over 3 onto each side. See, if I put the power 2 over 3, then 2 over 3 over here. So it's u to the power 2 over 3 equals x to the power half. So when you have powers like this, so the powers get multiplied, right? Since it's a bracket. These are laws of indices, basic laws. So you can see u to the power 2 over 3 equals x to the power 1 over 3, right? So we have 1 over 1 plus u to the power 2 over 3 dot du, okay? And now what you can do is, let's take another substitution. We could take a substitution of t equals 1 plus u to the power 2 over 3. Now I know these questions are MIT questions, so in the exams you can't take this much time. You have to do it really fast. But I'm just solving it as if it's a normal question for the ones who are not focusing on MIT. Like everyone would like to do questions like this, right? Like just give it a try. So you could do these questions. You don't have to rush. You can just take your time and do it, right? So t equals 1 plus u to the power 2 over 3. So dt over du equals 2 over 3 u to the power 2 over 3 minus 1, right? So 2 over 3 u to the power minus 1 over 3. So let's subject du. So we get 3 over 2 u to the power 1 over 3, right? Dt equals du. Yep. So now you can put that in. So we have 2 into 1 over. Oh, before going forward, let's find. Oh, so we had the substitution. So it's 1 over t. 1 over t into 3 over 2 So you can see the 2's cancel off. U to the power 1 over 3 dot dt. So dt. So we'll have to find what u to the power 1 over 3 is, right? So if t equals 1 plus u to the power 2 over 3, so how do you find u to the power 1 over 3? So you can write t minus 1 equals u to the power 2 over 3. And now to make the right side, to make u to the power 2 over 3 into 1 over 3, what do you do? So we'll have to put the powers of half, right? Half on the left, half on the right. So you can see these two will cancel off, and then you get u to the power 1 over 3. So u to the power 1 over 3 equals root t minus 1. So it's you can take the 3 outside. So we have the integration of root t minus 1 over t dot dt. So we got 2 substitutions so far, and guess what? Let's go for the third substitution. Yeah. So we'll take a substitution of w equals root t minus 1. So dw over dt equals t minus 1 to the power half. Half comes down. This is half minus 1, right? And the differentiation of t minus 1 is 1. So that won't matter. So you can write this as 1 over 2 root t minus 1, right? So 2 root t minus 1 dot dw equals dt. So let's make this substitution. So we have 3 into the integration of root t minus 1 over t dot dt. So instead of dt, we write 2 root t minus 1 dot dw. So now you have 6 into the integration of t minus 1 over t dot dw. So we got the substitution of w equals root t minus 1. So what is t minus 1? So we could just square both sides. So w squared equals t minus 1, and t equals w squared plus 1, right? So now we have the integration of w squared over w squared plus 1 dot dw. Now this is easy. You don't need any more substitutions. So first, without solving this question further, we'll have to break this into a partial fraction, right? So how do you do that? So you could divide w squared by w squared plus 1. So w squared divided by w squared is 1. 1 into w squared is w squared. 1 into 1 is plus 1. So the remainder is minus 1, right? So you could write w squared over w squared plus 1 equals 1. 1 minus 1 over w squared plus 1, right? So now we have the integration of 6 into 1 minus 1 over w squared plus 1 dot dw. So how do you integrate this? So what's the we can leave the 6 aside for now. What's the integration of 1 in terms of w? So it's w, right? Minus the integration 1 over w squared plus 1 dot dw. Now what is this? How do you integrate that? Let me write it with black. What's the integration of 1 over w squared plus 1? But that's easy. You should know that. So it's tan inverse w, right? Plus c. Plus c. I wrote 6 instead. Plus c minus 6w here. So this is a basic formula. I could show that to you guys. I could prove it to you guys. I have it in one of my previous videos. In one of my older videos, I've shown of how I got the differentiation of tan inverse w. So anyways, you guys have to remember this. You guys don't have to always show off how you get it. So yeah, if you guys have any doubts with that, please drop a comment. I'll help you guys out. So this is your final answer. Now let's put in the substitutions. So we had W equals root T minus 1, right? And we had T equals 1 plus U to the power 2 over 3, right? And we had U equals root X. 3 substitutions. So let's put T equals 1 plus U to the power 2 over 3 into this. So we get W equals root 1 plus U to the power 2 over 3 minus 1. These cancel off. Now we have U to the power 2 over 3 to the power half. The 2's will cancel off. Now we have U to the power 1 over 3. So W equals U to the power 1 over 3. And you know U equals root X, right? So W equals X to the power half to the power 1 over 3. So W equals X to the power 1 over 6. Now you can make your final substitution. 6 x to the power 1 over 6 minus tan inverse, it's 6 minus 6 tan inverse x to the power 1 over 6 plus C. This is your final answer. It's an easy question. You just have to take three different substitutions. So this is the easiest way of understanding of, I would say the easiest way, because this is basic integration, right? Integration by substitutions, that's the basic, that's like the pillar of, it's at the base of integration, right? Those are the stuff you learn at the start. So I would say when approaching these type of questions, you could try with the basics, right? So definitely there's definitely a lot of other methods of doing this. So yeah, you can do any way you like. So if you guys understood of what I did, if you guys have any doubts, please drop a comment. I'll help you guys out. And if you guys like my video, leave a like and subscribe. Thank you so much. Have a great day.